Good morning, ladies and gentlemen. We're just going to take a few moments and wait for some additional attendees to join. We'll get started in about 2 minutes. Good morning, ladies and gentlemen, and welcome to today's webinar, Running Microsoft Workloads on AWS. My name is Mark Teistel. I'm a solutions architect based out of Melbourne, Australia, and I'm delighted to share with you today this webinar. What we're going to look at today is effectively 6 key areas. We're going to look at Microsoft and AWS. That will give you a basic introduction into the different technology suites and capabilities that AWS has in terms of running Microsoft workloads. We're going to dig into why running Microsoft workloads on AWS. What are the strengths, features, and benefits of running these workloads on AWS? Of course, everybody would like to get started and try this out for themselves. So we'll have a look at how do you actually get started in turning on your Microsoft workload on AWS. We'll have a look at Microsoft Server products relate to being able to be run on the AWS platform. We'll talk a little bit about how do you do migrations and what are the key considerations when you're looking at migrating Microsoft workloads from an on-premises environment to the AWS platform. Then we'll have a discussion around some licensing options, which is a crucial part of any Microsoft workload. We'll hopefully have a few moments at the end to take some questions. I have with me today Danny, who will be taking your questions online. So if you do have questions at any time, please feel free to shoot the questions across using the questions tab in the GoToWebinar control panel, and we'd be more than happy to answer those for you. So with that, let's get started on our journey today. So Microsoft and AWS. AWS, as you know, is a cloud computing platform that's optimized for Windows-based or Microsoft workloads. This platform provides a wide range of scalable services, and these services align to maturing and ever-changing business needs. Within AWS, we have a dedicated team responsible for focusing on Microsoft workloads. Their key accountabilities are for delivering a highly secure, reliable, performant, familiar, cost-effective, extensive, and flexible offering that supports all of your Microsoft workloads. In terms of AWS experience and Microsoft workloads, we launched Windows support on the AWS platform in October of 2008. And this launch covered all the use cases that were available, covering all industries. And today we provide Significant choice of operating systems in the Microsoft world, with images ranging from Microsoft Server 2003 Release 2 all the way up to the recently released 2016. We have a very wide range of portfolio offerings across Microsoft platforms. This includes delivery of Microsoft desktops through our Workspaces platform, SQL Server, Managed Active Directory. We have a number of quick starts and quick implementation guides for SharePoint, Exchange, and Lync. Across our fleet of EC2, our Elastic Compute Cloud instance types, we cover about 50 different types that are suitable for running Windows workloads. This covers both 32 and 64-bit platforms, either optimized for CPU, GPU, memory, or storage, and more recently with our reInvent announcements, even FPGA support. Within AWS, we have a comprehensive team that's responsible for creating and maintaining Amazon machine images, which represent the boot images with the operating systems, maintaining these AMIs, patches, and drivers to ensure that the Microsoft workloads that you're running are consistently run in a secure, reliable, highly performant, and flexible fashion. We also supply a whole range of getting started guides, documentation, white papers, reference architectures, and quick starts, as well as a number of frequently asked questions, including guidance around licensing. Microsoft workloads are supported very platform. AWS fully supports Windows Server as both infrastructure and as a platform. Thousands of our customers have successfully deployed in the AWS cloud pretty much every Microsoft application that's available today, including Exchange, SharePoint, Lync, Microsoft Dynamics, and even remote desktop services. Now, if you are running Microsoft, you're struggling, please feel free to reach out to our fantastic support organization, and they'll be able to work with you to resolve any issues you may have. In terms of the relationship that AWS has with Microsoft, AWS is a member of the Microsoft Partner Network. We're licensed to sell Microsoft software via our SPLA agreements. We're a gold certified hosting partner with an active Microsoft Premier Support agreement. So not only are the Microsoft services backed by the extensive capability of the AWS platform and the AWS support organization, AWS itself is heavily supported by Microsoft organization itself. So should we have support issues, how do we deal with these in the Microsoft environment? First of all, we encourage you to call AWS support. If we identify a problem with a Microsoft product on which the underlying issues extend past AWS technologies, then we leverage the strong relationship that we have with Microsoft, and they will work in a coordinated fashion with AWS to ensure that we resolve your issue. However, please make sure that you reach out to the AWS support organization to raise any of these cases. So support is very important because we support every imaginable use case. We support all sorts of migration capabilities, including partial and full migrations. We see Microsoft workloads being used across web, mobile, and media. Productivity and collaboration, as I mentioned before, across the extensive support of Microsoft server-type products, CRM and ERP deployments, virtual desktops, big data and analytics, and of course, intelligence. For example, GPT has migrated most of its data center to the AWS cloud, with 70% of that migration being a straight lift and shift. During the this move, their SAP system was Active Directory is in the process footprint from 34 to 4 data centers over the next 3 years. Whilst doing this, they're achieving a 52% reduction in the total cost of ownership by moving their solutions services and products to the AWS platform has chosen to run reason cut their non-Microsoft workloads on AWS. And this the compatibility of our x86 virtualization technology, our storage, and our compute is done at an enormous scale, which means our customers benefit from the experience learned from millions of customers that have used the platform before them. Customers are able to choose from an extensive suite of VMs and network performance options, including everything from our T2 up to our largest X1 instance type, and be able to customize their storage and network options based on any region and any availability zone in the world. In terms of scale, we currently support 13 regions, 35 availability zones. I believe after reInvent, that's now 38, with each availability zone being at least one or more data centers with over 50,000 servers per data center, greater than 100 terabits between them. Of 4 regions, there are 9 availability zones within those regions. This is especially true within the United States. Within our ecosystem, we have tens of thousands of partners with at least 2,700 marketplace products that enable our customers to deploy solutions with a click of a button. So in many ways, you can think of the marketplace as an app store for AWS. So I've spoken a little bit about why we run workloads on AWS, and I've mentioned some terms like regions and availability zones. I'll take a moment just to drill into this and talk on reliability of our solutions and services as quickly as possible. And from the Microsoft perspective, that have been built in reflects this experience, and this is now available to you as our customers. So we'll drill in a little bit as to why run specifically Microsoft workloads on AWS. Effectively, there are 5 key areas that we like to think are important for our customers to understand about reasons to run their workloads on AWS. First of all, the AWS platform is enabled for compliance. Across the platform, we provide NIST, PCI accelerators, we supply a whole range of certifications and compliance and regulatory controls as well. And we have services, features, and enable our customers to manage both the security of the cloud and security in the cloud. Now, specifically, compliance for Microsoft workloads starts at the seemingly simplest level. However, we can think of things like security groups as a great example. A security group is a layer 4 stateful firewall which protects IP source and destination and port source and destination pairs. They protect every network interface of every instance within AWS. This This is also true of Microsoft workloads within AWS. This may sound a little bit tricky and cumbersome and potentially difficult to maintain. However, the opposite is true, where you can define the security group in terms of what traffic from what other security groups is valid. Things are very, very easy. This allows our customers, yourselves, to decorate the instance or interface with the security groups which apply, and then that's done. So let's say you start with one VPC, and in that you have your workloads and your Active Directory controllers. You create a security group for your domain members and another for your domain controllers. Your domain can access your controllers and vice versa. Controllers can replicate, but no crosstalk between the members would be allowed. Now let's assume that over time you evolve this design and you add more VPCs or virtual private clouds in more accounts that enable you to segregate your business systems and manage risk through this. The network paths are in place, so every domain member, no matter what its IP address, will be allowed to talk to all domain controllers, not just its primary domain controller. So if you add or remove a domain controller, you don't need to update anything by placing it in the security group. Every member automatically has access to the same security when retiring. So these are just some of the strong points around compliance, and an example they're using security groups and how compliance can be made quite easy in the AWS environment. License management is another key factor that our customers consider. With AWS Config, which is a service that you can consume, we track and prove that licenses that need to be server bound are in fact used exclusively on dedicated servers. We have a feature called Dedicated Hosts for this requirement. AWS Config allows you to monitor and report that software never roams beyond the assigned hosts. And this is an extremely important aspect for our customers who have specific licensing agreements or host-based licensing agreements with Microsoft. Auditability is built into the AWS platform. Using AWS CloudTrail, you can monitor every API call made to the platform. VPC flow logs also provide every network packet, and this enables you to audit at the network level. AWS Config will capture every change in infrastructure, whilst AWS Inspector lets you analyze the behavior of the AWS resources, including instances, network, volumes, and process activity, and use this to identify potential security issues as they may be occurring on the platform. DevOps, pretty hot term in the industry right now, is a built-in capability when you're running Microsoft workloads on AWS. For example, AWS allows you to build consistent, predictable, reliable infrastructure such as networks, instances, gateways and firewalls, etc., and allow them to be deployed repeatably with confidence. Combining this with PowerShell lets you build additional capability when you're deploying Microsoft workloads. For example, CloudFormation can ask an instance to call out and update a version or to pull down some code using PowerShell. PowerShell is embedded into CloudFormation so that they run seamlessly together. Optimization is another key aspect that our customers like to think about when running Windows workloads on AWS. This is where our customers can choose things like input-outputs per second and provision these across the platform, for example, with their EBS volumes to ensure that they have sufficient capacity on and off the disk volumes that they choose to use with their Windows-enabled EC2 instances. I've spoken quite a bit about security already this morning. What I'd like to do is take a little bit more of a deep dive into this and talk about the AWS shared responsibility model. So, AWS looks after security of the cloud. And this is a section you can see here below the orange line labeled with AWS Web Services. This covers things like compute, storage, and database, as well as the underlying AWS global infrastructure, as I've mentioned before, our availability zones, our regions, and our edge locations. Customers really value the fact that AWS takes into account and is responsible for security of the cloud, so they can focus on delivering solutions and products to their customers that raise the value of their business. In many ways, AWS does the undifferentiated heavy lifting across a whole range of technologies to ensure our customers get the best of both worlds in terms of security and flexibility. Above the line in this model, you'll see a section of the architecture model allocated to customers. And this is where the shared security model separates, and where customers are responsible for their security and compliance in the cloud. For example, should you deploy specific applications, specific client-side encryption methodologies or network traffic protection, customers are responsible for security of these deployments whilst they're in the cloud. And in many ways, this is no different to the way that you're operating your infrastructure today, should that infrastructure be on premises. So what I'd like to do is have a discussion now around what are the tools that AWS provides you from a responsibility of looking after security and compliance in the cloud to ensure that you can do this in a stable, scalable way. And we have a number of services, and I've touched on these already. AWS CloudTrail for capturing all calls made to the AWS API. Amazon Inspector that allows you to have a look what's going on in your actual instances. EC2 to do configuration config to manage configuration changes to your environment. We have our AWS IAM, which is Identity, Access and Management, which is a very comprehensive suite of tools and capability that enables you to control access at all levels of the AWS platform to specific resources and specific users. You'll also notice in here we have Cloud HSM and AWS. These are our encryption methodologies, and these can be used to encrypt data at rest and in motion, and can also be used to encrypt data within your own application. The beauty about using these services from an encryption standpoint is that key rotation, key encryption, and key security is all looked after by AWS, which is again another example of how AWS takes on board a lot of the undifferentiated heavy lifting, enabling you to focus on delivering value to your end customers. So within AWS, we believe in creating building blocks that can be composed and reused to create greater value. And this is where we take care of undifferentiated heavy lifting. Not just in technology though, but also in automation, in processes, in experience, security, and operational excellence. The benefit here is that by building these building blocks and primitives, we increase the reliability of the solutions that our customers on top of the platform. For example, the AWS region and availability zone model, Amazon S3 and EC2, auto scaling groups, and elastic load balancers are all building blocks of stable, scalable, reliable infrastructure, and when used together, deliver a low-cost, highly available, scalable system. What this enables our customers to do is to achieve levels of reliability that were previously cost prohibitive and generally not achievable by many enterprises. So some of the questions that we ask ourselves when we talk with customers is what's changed in terms of the total cost of ownership when we're looking at availability? So should we try to deploy some of these technologies and capabilities ourselves? How would the total cost of ownership model look, and how would that cost-benefit analysis appear when we come to make investment decisions? We also ask, what should a business now expect? So when you have increased levels of reliability, when you have AWS taking care of the undifferentiated heavy lifting, what can the business now expect as benefits? What are needed to achieve these benefits? And we also look at disaster recovery and business continuity planning. And in the new world of AWS Cloud, how these changes might allow our business to deliver better outcomes for our customers. Let's have a look at an example of how this may actually work in the real world. So you can see here quite a typical example of a deployed multi-tier Windows workload And you'll notice here we've got a number of users who are using CloudFront, who are making DNS to Route 53, which is returning a URL through CloudFront. CloudFront is our content distribution network. The CloudFront content distribution network forwarding those users to one or more elastic load balancers. Those elastic load balancers are spread across 2 availability zones for high availability and are able to forward traffic to both or one in the event of a failure or in the event of an upgrade scenario, IIS servers. Behind the IIS web servers, we have again internal elastic load balancers that are able to load balance traffic to IIS application servers. And behind the application servers, we have a highly available MS SQL deployment using Amazon RDS, our relational database service. So let's go through each one of these and have a look at these and understand exactly what they do in detail and how we can make this solution robust and scalable. One of the things that we can do is we can use the Amazon Certificate Manager to deploy our certificates into the CloudFront distribution. This enables us to manage certificates in a very scalable way, and also to ensure that there's a renewal of these certificates when the time comes. You'll notice there's a NAT gateway in this solution, which provides us resilient capability for managing egress traffic out from private IP addressed hosts within our availability zones. Our IIS servers are placed into auto-scaling groups. Auto-scaling groups enable us to horizontally scale and add additional capacity based on EC2 instances to our elastic load balancers at times of peak demand. The definition of peak demand is up to our customer, and this can be defined based on CloudWatch events, CloudWatch metrics, or even the applications themselves can trigger the scaling out and the addition of additional application servers and web servers into that tier of the architecture. So you can see here there's a significant amount of capability that is included in the AWS platform when delivering Microsoft workloads on AWS. You'll also notice on the far right we've got machine images in S3. S3 is our durable object store, and the machine images that represent the application servers and the web servers that are deployed into the architecture are stored inside S3. These are pulled on at boot time by the EC2 instances when they are triggered by the auto-scaling group. This enables you, for example, also to manage upgrades of your operating systems and patching very effectively as well. So how would you build a platform like this on AWS? Well, you could sit down and design it all by hand and have many great whiteboard sessions that we all love to have with our organizations. Or we could look at using the significant amount of quick starts that AWS makes available. These are single-click deployments that enable you to deploy some quite complex architectures that are well tested, that are highly available, that include extensive documentation, and they represent years of customer deployments and AWS best practices. And these quick starts are fully functional. These are not demos or proof of concepts. These can be deployed into production and tailored to meet the needs of your organization. For example, Windows SQL Server with Windows Server clustering, SharePoint, Lync, and Exchange, PowerShell, DSC with remote desktop gateways, Active Directory and ADFS, NIST and NIST high impact deployments, and PCI DSS deployments are all available in our quick start selection. So I encourage you all to go to aws.amazon.com/quickstart and have a look at the quick starts that are available there today that can really accelerate your adoption of the AWS cloud and your migration of your workloads into the AWS cloud to lower your costs and improve your high availability, durability, and redundancy. Many of our customers ask us to step back and talk to them about, once this infrastructure is deployed into AWS, how do they actually connect their corporate data center to the AWS cloud? So when we step back we actually offer two different solutions to do this. The first solution, is a VPN tunnel. This is an IPsec tunnel that's built with data center and the AWS cloud. In fact, this is a connection between your corporate data center and a VPC within the AWS cloud. We support static and BGP routing across VPN tunnels, and we support varying multi-megabit per second speeds. However, this is a VPN tunnel across the public internet. Many of our customers have asked us for the support for private infrastructure for connecting corporate data centers to the AWS cloud. This is where we introduce our service called Direct Connect. Direct Connect is a service that allows for dedicated telecommunication provider links from your location to an AWS demarcation, which will allow you to connect to the AWS cloud. This provides telco-grade SLAs and predictable performance for traffic across the link. We're able to provide multiple 1 gigabit and 10 gigabit links per customers. And here we support BGP for dynamic routing and AWS-driven API endpoints. So the provisioning, maintenance, and management of these Direct Connect links can be automated through your corporate data center using the AWS API endpoints. Let's take a look at an actual reference architecture here. And this is the remote desktop gateway reference architecture. And again, if you have a look, there's a link down the bottom. We'll make these links available at the end of the session. There's some detailed instructions about how to deploy this solution. But let's have a look at this reference architecture in terms of how would we deploy a highly available remote desktop gateway solution. You may have remote desktop users sitting out there on the left that need to access, for example, a domain controller. This could be an administrator who needs to maintain it, or it could even be users who need to authenticate against these domain controllers. You'll notice here there's 2 availability zones and 2 domain controllers, but there is only 1 remote desktop gateway. So you could imagine a scenario where, for example, you may want to do some maintenance on this remote desktop gateway. If that was the case in this architecture, there would be a problem. You would need to schedule that downtime because your customers would lose access to the domain controllers. However, using the suite of tools we've already discussed today, we can easily provide highly available solutions to this challenge. We can deploy a second remote desktop gateway, as shown here in the top availability zone, and each remote desktop gateway has access to each domain controller across the availability zones. Secondly, we can deploy Route 53 and include health checks in our Route 53 service to check that the remote desktop gateway is available. So should a remote desktop gateway fail or be brought down on purpose for maintenance, Route 53 would notice that primary remote desktop gateway has gone down, would change its DNS announcements, provide DNS failover to the backup or the second remote desktop gateway. Indeed, we could even load balance using DNS load balancing across both remote desktop gateways. So you can see here, without dramatically changing your architecture, you can introduce a highly available solution very, very easily. We have a range of tools, as I've touched on earlier, in order to do this. If you look at this from a Windows perspective, I'll start by talking about AWS tools for PowerShell. With PowerShell, we have over 900 commandlets that are there for interacting with the AWS ecosystem. This is for talking to our AWS using PowerShell. We also have available the EC2 run command, which I'll talk about a little bit later. This is very similar to the services that you'd be familiar with called SSM. AWS config, which I've touched on as well. Within monitoring, we can make use of AWS CloudWatch, which enables us to create alarms and events based on certain criteria and conditions that are occurring within our infrastructure, and AWS CloudTrail, which I've touched on earlier for capturing all API calls. Now, of course, we need to deploy infrastructure, we need to deploy code, and we need to manage it. We have a suite of services, solutions, and products across that capability. So we can look at things like using the .NET SDK, the AWS toolkit for Visual Studio, which is an extremely rich toolkit for interacting with AWS APIs, services, and capabilities. AWS Code Deploy for deploying your code out into the infrastructure. Elastic Beanstalk for deploying the infrastructure along with that code. AWS CloudFormation for immutable, repeatable infrastructure deployments, and AWS OpsWorks as well. So you can see available to you is a very rich suite of tools and capability to deploy your Microsoft and Windows-based workloads. I did say I would touch on the EC2 run command. This is also known as the Simple Systems Manager. The EC2 run command enables you to reduce the direct access that staff requires to your servers. You can build commands that get deployed to your fleet of Windows-enabled EC2 instances without users having to log on to execute those commands. Those commands through the EC2 run command can then be deployed to one or many or a subset of your fleet of Windows servers on the AWS platform. It's a very familiar type service. It uses the already included EC2 config Windows service. So for those of you who are familiar with that, the change to using EC2 run command is very straightforward. It facilitates automation by enabling common administrative tasks at scale. EC2 config polls every 5 minutes, and it forces calls through the API, which can then trigger EC2 run commands. Security being job zero at AWS, EC2 run command integrates seamlessly with AWS IAM. This manages what users can and cannot do and enables you to provide roles to EC2 instances, and these roles can limit what these EC2 instances can and cannot do. Therefore, when you execute an EC2 run command, that run command must be compliant with what that EC2 instance or that user that's been assumed on that instance can or can't do. CloudTrail, again, provides us visibility in the tracking of any configuration changes that we might trigger with the EC2 run command. And the beauty of this is it's extremely customizable. So you can create custom actions to automate common tasks that are relevant to your business. These may be tasks that haven't been foreseen or catered for by AWS or by others in the industry. So you can create these custom actions. When you tie together these 6 key points, and you add the final one that you can now manage servers outside of AWS, which means the EC2 run command is available to be run on premises, you now have the ability to manage your fleet of Windows servers seamlessly across AWS and your on-premises environment. This is extremely powerful for when you're looking to deploy a migration. So we're going to quickly run through Microsoft Active Directory on AWS. Now, one of the things that's interesting I'll just touch on is we've just recently released Active Directory schema extension support. So this has now opened up the ability for many, many third-party applications to integrate with Microsoft Active Directory on AWS, where these options may previously not have existed. So for those of you who have looked at this and had applications that required schema extensions, I encourage you to go back and reevaluate whether Active Directory on AWS is now a solution that you could use. Please reach out to your SA team and your account team to get some guidance should you need it. Quite often we have a conversation with our customers around the creation of a new Active Directory, or do we extend what we already have on premises? So lots of customers choose to create a new or a fresh Active Directory in AWS on EC2 and to extend the trust for single sign-on between AWS and their on-premises. Potentially, they may also bring a replica of their Active Directory environment into AWS for resilience. Now, if you run your own Active Directory servers, you can treat each availability zone as an Active Directory site, and this gives you high availability very quickly and very easily. And you're able, if you're extending, you're able to provide read-only domain controllers. They still need network connectivity, but they can be read-only in the AWS environment. Now, AWS provides a managed Active Directory service that simplifies the creation and deployment of Active Directory on AWS. There is a number of different flavors of this, and we're going to touch on each one of these. Simple Active Directory is based on Samba, which is an Active Directory compatible service, which is fully managed by AWS. This is good for small deployments where you don't have to worry about creating machines or configuring settings or promoting domain controllers or managing backup. We do all the undifferentiated heavy lift behind the scenes is done for you, and the interface is via the AWS console. And this enables you to focus on delivering your business value, like managing the actual user accounts and group memberships. And this is the Simple Active Directory service. We also have the AD connector. The AD connector is the best option if you want to use your existing on-premises Active Directory with AWS without extending your domain into the cloud. So this will enable you to connect your services and applications back to your on-premises. Now, we also have an Active Directory service based on Microsoft Active Directory Enterprise Edition. Again, this is a fully managed service, which is really good if you have requirement for 5,000 users or more, and you need a trust relationship set up in the AWS hosted directory and your on-premises directory. This is based on Windows Enterprise Edition 2012 and is a fully managed service as well. Microsoft SQL Server on AWS. We have a wide array of choices of our managed service. These are enterprise-grade deployments that have enterprise-grade security. They're highly available, they're flexible, and they're scalable. And we really provide two options here. You can run SQL Server on a Windows EC2 instance, or you can take advantage of our RDS, our Relational Database Service. RDS takes care of all of the time-consuming database management tasks, such as backups, patch management, and replication, which allows you to focus on, again, delivering the value application development and things that are important to you and your customers. If you choose to use SQL and EC2, you will be responsible for managing that infrastructure, as opposed to RDS, where you're only responsible for operating the database yourself and interacting with that database. AWS provides a variety of versions of SQL Server, from Web, Standard, and Enterprise editions. We provide enterprise-grade security with integration with AWS Amazon VPCs, where you have full control over the network and integration with Amazon KMS and Cloud HSM. So you have full control of encryption over the data stored in that database, and that you can make sure all the data that you have in AWS is always secure. Again, this is offered with high availability that's fully flexible and scalable, so you can adjust the size of that infrastructure up or down in an on-demand basis as meets your needs. Let's have a look at a simple model like this. So where a customer determines that a managed SQL Server through RDS is not possible, as I've mentioned, you can run SQL Server on EC2. This example here shows SQL Server set up with synchronous replication in an always-on availability group. This effectively achieves an RPO of 0, since data is committed to both zones before a transaction is completed. Multiple IP addresses are assigned to the network interface cards, with the auto-scaling group listener address bound in DNS, so the clients access their cluster consistently during failover events. This gives an extremely high availability EC2-backed solution where RDS is not possible. One of the ways that we look to help our customers scale is the concept of a read replica. So taking the previous example, we now extend this example with a file server witness and a second replica, but this time configured for asynchronous replication only, since it's only to be used for reporting purposes. This sort of model allows the file server to use the read replica where the load might be high, therefore not impacting, for example, the primary. So this gives, again, further high availability and further performance improvements across the Microsoft SQL deployment. Now, the examples I've just showed you is where it was not possible for one reason or another to deploy Amazon RDS for SQL Server. However, there are a multitude of examples where Amazon RDS can be deployed. The benefits of Amazon RDS relate to about 8 or 9 key points, but effectively, again, AWS taking care of all the undifferentiated heavy lifting, looking after high availability, host replacement, patching, backups, and point-in-time recovery, as well as integrated Windows authentication with Active Directory. So how do you make a decision about which is the right solution? We always ask our customers to consider RDS first because it enables them to focus on their high-value business tasks, making our customers only responsible for high-level tuning of queries and schema optimization. Therefore, no in-house database administration requirements are there for those organizations who can leverage RDS. If RDS is not possible, we then recommend SQL Server on Amazon EC2. In this case, customers have absolute full control over their and reliance on the DB instance itself, backups, replication, and clustering. It's possible maybe some capability or some options not available yet today on Amazon RDS, and therefore the EC2 option is the way to go. So when we pull all this together, we can deploy extremely capable Microsoft workloads within AWS. And you can notice here from this example, we have a public subnet in both availability zones providing high availability access. We have our remote desktop gateways, as we showed in our previous example. We also have a 3-tier application service with our web servers, our application, and our databases. But you'll also notice we've tied in together our direct connect services on the right-hand side to provide access from our corporate office. So let's have a quick look through this and see what are the connection patterns that our customers would experience and our users would experience as they leverage this infrastructure. You can notice here that our remote users would come in through the internet gateway. They would attach to an elastic load balancer that would load balance traffic across the 2 front-end web services in a private subnet. We have an alternate set of access as well from our corporate office, and this is where we may leverage either the VPN service, which is an IPsec VPN tunnel built across the internet, or the telco provisioned AWS Direct Connect service. In this case, we would still leverage the same internal mechanisms. However, we would access a slightly different load balancer that would again allow our internal corporate office access to be load balanced to gain access to our 2 front-end web servers. So you can see here a possible architecture for a Microsoft workload. This could be something as simple as SharePoint, but it could also be an extremely complex, custom-written, multi-tier web application. Again, I encourage you to look at our quick starts, which will help you deploy this quickly and seamlessly without the requirement for heavy technology understanding, and will enable you to incrementally learn the solutions and to tailor on an as-need basis. So which brings us to what can you actually run on AWS? So what are the Microsoft Server products that can be run? Well, the complete suite of corporate applications can be run. Windows Server, SharePoint, Exchange, SQL Server, Microsoft Dynamics, Microsoft System Center. These can be deployed in highly available fashion. They can be deployed in a bring your own or a pay-per-use option. There are multiple security layer approaches that we can suggest, whether that's through the quick starts or through consultation on best practices or engagement with your account team and solution architects. And all of these allow you to leverage the multi-AZ architecture for reliability and availability across the AWS platform. So these are all instantly recognizable server products. What's important to think about here is how do we right-size the infrastructure that is required to support these? How do we do this with multi-availability zones and high availability? How do we meet our compliance and security requirements? And how do we access availability to test these services before they go into production? This is where I'd like to introduce the concept of the Microsoft Server Enterprise Accelerator. This is a complete solution that deploys 14 servers across 2 availability zones. It's deployed from a single master CloudFormation template. It deploys Exchange, SharePoint, Lync, SQL Server, and Active Directory on AWS. It supports 10,000 users, with each user having 5 gigabytes of mailboxes. There's 1 terabyte of SSD provisioned for user profiles. The enablement of VoIP, video and web conferencing and desktop sharing using Lync. SharePoint blog and team sites are everyone enabled, which means everybody in that organization can access it. And this can be delivered for as little as $14 per hour based on Oregon regional pricing. So this is an accelerator model that very quickly enables organizations to spin up enterprise-grade solutions that can support 10,000 users for $14 an hour. This is an extremely capable solution, and again, I encourage you to have a look at this and to stand this up yourself and have a play with the solution. It's quite a lot of fun to play with. At AWS, we believe that we should be using our own technology. In 2013, Amazon IT decided to migrate its Microsoft stack to AWS. Over 200,000 Amazon users requiring access to Exchange, SharePoint, and Lync were migrated into AWS. So just to give you some data points on the scale of this migration, 26 Exchange servers, there were 4 per availability zone, 7,600 users per server, DAG architecture was used for high availability, and this now supports users of Amazon in the Americas, EMEA, and Asia, which is a good portion of Amazon's global footprint. So not only do we advocate our customers and partners leveraging Microsoft workloads on AWS, Amazon, one of our large customers, has all complete Microsoft Exchange, SharePoint, Lync implementation users to AWS. One of the things that's very important when we think about moving Microsoft workloads into AWS is about licensing. So I'd just like to take a few moments before we wrap up to talk about licensing. We offer a service called an EC2 Dedicated Host. This is a physical EC2 server that's dedicated for your use. It's specified in terms of physical processes and cores, and it enables you to allocate and release on demand, but to reserve the capacity for a term. Now, why is this important? It's important because it enables you to have per socket or per core licensing. We use AWS config as the source data for license reporting, but also we encourage you to tag your resources so you can report as well. This enables the compliance to your licensing agreements with Microsoft through controlling instance placements on this host over time. It enables you to leverage your bring your own licensing without software assurance. So for those of you with software assurance, you'll be able to use other methodologies. But for those of you with bring your own licensing capability but without software assurance, Dedicated Host will enable you to take advantage of all of the benefits of the AWS platform we've just spoken about. In terms of licensing, we support bring your own licensing for Exchange, Skype for Business, SharePoint, System Center, etc. Pretty much everything you can think of in terms of Microsoft products, we support bring your own licensing. We also have license included options for our Microsoft related Amazon machine images, everything from Windows Server 2012 all the way through to SQL Server 2016. This enables you to basically point and click and to have your license included image costs on a per hourly basis. We have a large collection of operating systems, large collection of databases, everything from SQL Express and standard editions all the way through to SQL Server 2016 Enterprise. So I encourage you to have a look at the AWS licensing. You can see some links there, and we'll make sure that this is available to you after today's webinar as well. So I'm not going to spend too long going through this slide, but you can basically see here the 3 verticals or the 3 types of Microsoft product licensing on Amazon EC2. where AWS provides the licensing, and the licensing costs are included in the EC2 per hour costs. AWS Plus bring your own licensing, where you can leverage your Microsoft License Mobility program, and you can bring these costs, and this is where you'll bring we will provide the Windows Server licensing, and you'll bring your own application licensing, or a full bring your own licensing. And this leverages the EC2 Dedicated Hosts with software assurance. However, neither software assurance and licensing mobility are required. And what this does is this basically gives us a continuum of licensing options for our Microsoft customers. The beauty of the AWS provided solution is that AWS will take care of all the licensing. As you right size, you'll get benefits. You won't have to worry about complex contractual agreements with Microsoft. No CALs are required, and this is very simple pay-as-you-go model. AWS Plus bring your own licensing enables you to leverage agreements you may already have in place, and enables you to realize some savings through the reuse of existing licenses as well. Bring your own license gives you the ability to import and use your own Microsoft licensing. Software assurance and license mobility is not needed in full BY bring your own. You can use our dedicated hosts EC2 options, and you can manage all of your licensing and cost compliance yourself, and you can save through the reuse of your existing licenses. Now, there are a number of resources available to you. We encourage you on your journey to reach out. We encourage you to get in contact with your solutions architect, with our professional services organization, and our premium support. For those of you who'd like to work with partners, we encourage you to explore the AWS Partner Network, to reach out for partners that can assist you either to get started on, accelerate, or even to complete part of your journey. Now, just before I wrap up, I'd like to say thank you to everybody. I'd also like to let everybody know that you will all get training credits to do the Windows on AWS Learning Quests. We'll send you an email shortly on how you can redeem these training credits, as well as information around some boot camps we've got coming up next year, that if you'd like to extend your knowledge and dive deeper on some of the issues and aspects of Windows workloads on AWS that I've touched on today, you'll be able to do that. With that said, I'd like to thank everybody very much for their time today. I look forward to working with you as you deploy your Windows workloads on AWS. Thank you very much.